Today I'm going to look inside of another burnt out LED light bulb. This time a BR30 style lamp. This one uses 9 watts of electricity at 120 volts and is designed to output 665 lumens of light with 2700K color temperature. This light bulb was originally installed in one of these type of light fixtures, a recessed ceiling can light fixture. And this bulb has given some issues where it has flickered, where some of the other light bulbs on the same circuit never flickered. But now it just became really dim. So I will test this. This time using a power meter as well. Let's plug it in and see what happens. As you can see, it lights up very dimly and is also flickering slightly. And you can see how this bulb is made up of 8 LED chips, it seems. It is currently using 0 watts, 0 amps, at 121 volts. So something seems to have gone open circuit inside of the bulb. But now I'm going to take a look inside of this. There's a gap around here, which seems I can pry apart. Perhaps using a bigger screwdriver will help. Oh, there's a hole in it. Just clips in. Seems to clip together. Let's keep opening it, and now we can see what is inside. It truly uses 8 LED chips, mounted on one board, mounted on an aluminum plate, or I think it's aluminum, for heat dissipation. Next, I will see if the capacitor is holding any charge. I have a multimeter set to 200 volts DC range, and I'll connect it to this connector, which is labeled EC1, implying electrolytic capacitor. 0.2 volts. The next connector, which is labeled DB1, 0 volts. So the capacitor is discharged. Knowing that, we can look at the circuit safely. Input power seems to come from this connector with labels L and N, goes to a rectifier, current control chip, and out to all these LEDs, and a capacitor seems to be mounted on the other side of the board to provide some smoothing to reduce flicker. Maybe this capacitor has been failing. Also in parallel to the capacitor is a resistor with a marking 304, which is 30, 4 zeros after it, for discharging the capacitor slowly when you turn off the switch. Disappointingly, there seems to be no part number on the main current control chip. Or if there is one, it is way too hard to read. There also seems to be an additional few diodes. But next, I will pry out this heatsink plate. I broke the bulb. I guess if it goes like that, we'll just break the bulb further. Well, it doesn't matter much, because now we can see the electrolytic capacitor and the mains incoming power connectors. Disappointingly, the heatsink is only this flat pan and does not really extend down the length of the bulb to provide additional cooling. But next I will remove the LED board from the metal plate to hopefully get a better look at the capacitor and internal wiring. The wiring that connects the lamp holder to this board is mounted with thermal paste, which is good. Seems that I need to continue breaking apart the lamp housing or pry the pan out of here somehow. Okay, the wires have popped out. Let's pry the pan out of here. And there is a wire that went from the board to the lamp socket. The wire that went to the middle terminal of the lamp socket seems to go through a resistor or a fuse, then to the board. But now we can see the capacitor they are using It's rated for 105 degrees Celsius max temperature operation, and from an unknown brand that I've never heard of course. It's rated for 56 microfarads at 160 volts. Now, interestingly, there is no LED with a black spot visible on it, which seems to make me think that the controller chip is broken, and not the LEDs. But I can try to test each one of the LEDs. It's time for the bench power supply to make a return. I have it set to 5 volts voltage and 1 milliamp current limit. Now I will test each LED on the board. Seems that these LEDs are 3 chip, try 9 volts. Oh, this LED lights up. Next one. Nothing, maybe it's the other way around. Why is this all different LEDs? Doesn't light up anyway, maybe 9 volts isn't enough. Maybe this LED has like 6 chips in it and needs 20 volts to run. There's many more chips at 16 volts. Let's try this one. Wait. Oh, this one's flickering. Seems like we have a bad LED. Try this one. Oh, works as intended. This one? Nothing? Probably. Reverse polarity supply. Yep, works as intended. This one? Oh, works perfectly. Have to look through the camera screen because these are so bright. This is working. How about the last one? Also working good. I wonder at what voltage this one needs to work well. Let's try raising the voltage to 30 volts. Still very, very dim. Looks like this LED is broken. Definitely seems that LED number 3 has some sort of failure in it that is preventing it from reaching full brightness. Once again, this is showing to be another failure of the LED chips instead of the power supply circuit. Perhaps if the LED cooling was a bit better than just a metal plate, the bulb would have lasted longer. Although, the fact that this was manufactured with thermal paste between the board and the cooling plate is good. And the other good thing is, despite this bulb's long usage, the capacitor is not showing any signs of bulging. Meaning the capacitor still seems to be working fine, even after all of its use in a high temperature environment. But anyways, this is what is inside of a BR30 LED light bulb. Anyways, make sure to subscribe for more videos.